The Pythagorean Theorem, quite possibly the most famous theorem in all of mathematics. We have done the quadratic formula now, the much more difficult, it's like Pythagorean Theorem on evolved steroids. Now we could do the Pythagorean Theorem, something that is technically part of our review unit for this whole geometry, which will build up to trigonometry unit. However, I gotta say, the Pythagorean theorem is one of those things that lots of people know. If I was to ask you, I'd say, what's the Pythagorean theorem? Maybe out there, and not everyone would, but a lot of people would be able to say, oh, that's a squared plus b squared equals c squared. However, if I ask you, okay, what does a, b, and c mean? Or how do you use it? That's when it really starts to fall off. Lots of people are like, I don't know. I just remember this formula. Doesn't that count? Well, it's nice to memorize the formula, but if you don't know how to use it, it's kind of like knowing the name of a tool, but not knowing what it's used for or how to use it. It's not really useful. So, might as well be better off just selling it or giving it back to the store. So this assignment, I'm going to help you remember, or maybe for the first time learn, what this is, how to use it, and when it's applicable. So, right off the bat, you will see we got our Desmos calculator on the right. The proof of the Pythagorean theorem, there are lots and lots of different ones if you look on Google. But this one I particularly like because you can see, oh, it just like kicked me out there. Interesting. You can see visually, if I scroll down here again. The whole point, geometrically proving this, is to try and figure out why a squared plus b squared equals c squared. So you can see what they've done here is they have contrasted squares that are a by b length and width, and then compare the green and the yellow. You could stare at this a while, see, pun intended, how eventually if you rearrange these little triangles and combine the squares, the shaded yellow area would be the same as the shaded green area. Now, there's a TED Talk, you could look Google as well, that I had here for years, how many ways are there to prove the Pythagorean theorem. That is a very efficient way of seeing lots of different proofs. There are geometric proofs like what you see on the right. There are longer mathematical proofs with equations, all sorts of different things. There's one that was like from Egypt with ropes. Lots of different ways to prove that, yes, a squared plus b squared equals c squared. But when do I use this and how do I use this? Well, let's dive right in and take a look immediately at this shape. This is a right triangle. How do we know it's a right triangle? Well, we reviewed triangles already. It has a right angle. And if it has this right angle, this 90-degree little box, it's automatically a right triangle. The Pythagorean theorem will only work on right triangles, and it is used to solve for one of the three sides. So it has nothing to do with angles. Trigonometry will do a little bit of, that involves angles. You can ignore, the only angle that matters is this 90 degree. It is used if you have two sides of a triangle to figure out what your third side is. Your A and your B are always going to be your smaller two sides, and they are interchangeable. So you could do 12 squared plus 29 squared, or you could do 29 squared plus 12 squared. That's fine. Your largest side is always your C. This is what's known as the hypotenuse, your longest side. These are what's known as your legs of the triangle. Okay? So a squared plus b squared equals c squared. If I was to write this out visually for this problem, 12 squared plus 29 squared equals x squared. This is an algebra problem. We can good old sad me. Now on the right side, x squared, to solve for x, we only have to get rid of the squared. So just like we've done throughout this year, to get rid of the squared, I could take the square root That means on the right side, I just have x, which is what I want. And on the left side, I could just copy this. I've got 12 squared plus 29 squared. This equation is something that you can type into Desmos. That's not a good box around that. Let's see. Oh, it's diagonal. I'm going to give up that attempt. Okay, I could type in, maybe I'll highlight it, this whole equation into Desmos and see what it gives me. So let's do it right now. So have open your calculator as always. You're going to hit the square root sign. If you don't know where that is, you press your icons down here. It's right next to pi and this ABC for different symbols right here. When you hit the square root, now be in the habit, even though they're interchangeable, let's always put our larger one first in case we have to do a minus. So I'm going to do 29 squared. Where is squared? It's right there. And then here's the trick. Remember, it was a plus for this problem. The trick is, if x is up here, if you're solving for your hypotenuse c, then you put a plus sign here. But if x is anywhere else, if it's down here where the 29 is, or if it's over here where the 12 is, instead of putting a plus, we put a minus. And because you can't ever have the square root of a smaller number minus a larger number, that's why it's good to be in the habit of using the larger number first every time. Even though it's a plus on this problem, and it technically doesn't matter, it'll get us in the habit of when we need to put a minus, making sure that we get a real solution and we don't have to redo it. Okay, you'll notice that when you type it in correctly, you get your answer. It's a long, disgusting decimal. Now, they don't want the whole decimal. Ooh, I'm still in highlighter mode. They don't want the decimal. Instead, they want rounded to the nearest tenth. A little reminder about rounding the nearest tenth. The tenth is the first digit after the decimal. We only then need to write the first and second number after the decimal. You could ignore everything else. And then we have to ask ourselves about the number to the right of the wall. I always draw the wall right after where I'm rounding. In this case, it's the tenth, so I draw it right after the first number. We ask ourselves, is this number that I've circled here, the one right of the wall, is it 5 or above? That means 5, 6, 7, 8, 9. If so, we give the 3, the 10th, a shove up to 4. If it's not, if it's 4 or below this circled number, then we leave this 3 low. No. So 5 or above, give it a shove. 4 or below, leave it alone. This circled number is 5 or above. 8 is greater than 5. So then I give this 3 a shove up to 4. So it becomes 31.4. All right. Now we're already over 8 minutes into our lesson, but that's fine because we have explained most, if not all, of what you will need now to complete this assignment. Now it'll be much simpler to do the rest of these. Because I see number 2, x is still up top. That means I could leave this plus in the middle. I just have to replace my numbers with 12 and 13. Well, 12 copies, so I can just replace this 29 with 13. And then bam, I've got 17.69. So I look at my second number. Is that 5 or above? Yep, 9's greater than 5, so it's 17.7. And bam, we're rolling. Number 3, though, is the first example where x is not in our hypotenuse spot. Notice that's 33. Instead, it's on one of our legs. That's fine. That means that we're going to do our larger number first, so 33. But then instead of a plus in the middle, we replace it with a minus. And then our other number is 11. Oh, squared came down. I have to press that again. 31 point, first one, where the second number, is that 5 or above? No, it's 1, so we don't give it a shove, we leave it a low, no, to 31.1. Like I said, once we explain the first 8 minutes of what's going on, now we can just fly through these. Is x up top? Nope, it's not, so we're going to leave that minus and subtract, and now we've got 17 and 14, so I just have to replace my numbers. 14 and 14. Does this one round up? 6, 4. The 4 is not 5 or above, so it stays 9.6. Hopefully that little explanation has helped you round. Rounding is one of the things people struggle with for many years. You just need a good rhyming explanation. All in good timing. Okay. 11 and 6. X is still not in the hypotenuse, so I can leave the minus. 9.21 is going to stay 9.2. As always, hopefully you're using your numbers, not mine. You'll have similar problems, but different numbers. I could reuse the 11. It's just 8. 7.9. Oh, this is a good example of rounding. If you're still paying attention and not racing through your problems. Hi. Lots of people will round this as 7.6 because they'll look at this 9 and think, oh, that 9 rounds this 4 up to a 5, and that 5 rounds this 5 up to a 6. And that's a double rounding mistake. That's why I say in these situations, ignore everything. It's going to be more confusing to you. Literally cover it up, because now I can see, oh, that's 4 or below, literally a 4, so let's leave it alone. 7.5. That's the correct rounding. But if you don't cover it up, you can get confused. You could try double rounding, rounding up your first digit and then moving it over to the other digit and then moving it over. No, we only want to round once, cover up everything. This stays 7.5. I was hoping at some point in these videos I got to that exact rounding popular misconception because it's so common. I could hear people out there with their hands raised, like, what? This problem's broken. I want to flag it. It's like, oh, no, you double rounded. 7, once again, does not have x in the hypotenuse, so 31 and 12. That's straight up 28.6, rounds up. Because our second number is an 8. It's 5 or above. And you'll notice we started with 2 that we had to plus with x in the hypotenuse, and it's very fitting that we're going to end with an x in the hypotenuse. We've come full circle, rather full triangle, which means, you haven't changed this in a while, remember to make this minus a plus. And that your numbers are correct. That's 41.2. As I said, we spent 8 minutes doing the lesson, and then we did less than 5 minutes to do the problems. It's kind of like painting, you know. I don't know if you guys ever paint, but with painting, you could spend the vast majority of time putting like painter's tape everywhere, making sure that all your corners, your edges are all marked. And then once you do all that prep work, you get your paint out, you get the brushes, you stir it. When you start applying the paint itself, especially if you have a big roller, it goes really fast. Similarly, it took a long time to get set up, took a long time relative to the problems to talk about what was going on, give you some proofing background. And then once we actually dove into these 8 problems, super easy, super fast. Okay, hopefully you found that super easy and fast after my explanation. As always, best wishes on your day, your week, your whole life. This has been Digital Class with your teacher Dylan. Take care. Always continual best wishes. Until next time.